Welcome everybody to the March 2026 edition of our Lunch and Learn series. I'm going to share my screen here so we can go through some introductory remarks. So we'll do that. All right, so our presentation today is going to be about spatial representation learning. We have our guest, Dr. Zhangyu Wang, from the University of Maine's School of Computing Information Science. I'm Matt Doobie. I'm the vice chair of the Maine GIS user group and also a faculty member at the University of Maine at Augusta. So we have an upcoming Lunch and Learn next month on April 29th. We have two folks, Doug Suter and Adam Pepe from the Maine Department of Environmental Protection. They're going to talk about some new biological modeling tools that they have been working on. So that should be exciting for the group. On May 13th, we are running a Mappy Hour event at the Maine Municipal Association Technical Conference that will be at the University of Maine at Augusta. So that will start right after that event is over. So there will be refreshments and lightning talks that we will put together for people who are interested in attending that. Always a good time. I'd like to take a moment to thank our sponsors. So we have CAI Technologies, Esri, Maine Technical Source, Viewshed, the Maine Department of Agriculture, Conservation and Forestry, the Maine Department of Transportation, the Maine Office of GIS, the Maine Public Utilities Commission, the Raymond H. Folger Library at the University of Maine, and the Wheatland Geospatial Laboratory at the University of Maine. We have the Maine Geo Library, CGIS Solutions, Dirigo Spatial Systems, the Greater Portland Council of Governments, GEI Consultants, the St. George Consulting Group, Stantec, Stone Environmental, Wright Pierce, and a Kennebunkport and Wells Water District. So thank you to our sustaining sponsors for our organization. And now I'm going to introduce our speaker. We're going to talk about spatial representation and learning today. So our speaker is Assistant Professor of Spatial Computing. Is that correct? Or is it
Yep.
a different title? I know there are lots of titles in the school. I went to grad school there, so I'm familiar with that. So new to the UMaine faculty this year, correct?
Yep.
So
Correct.
welcome to the state of Maine on behalf of the professional view of the discipline. So this is a good opportunity to help foster some relationships. So I always like to get new faculty members for this so they can kind of show what they do. So with that, I'll stop sharing and I'll remind everyone that we have a question and answer feature here in the webinar. So if you have questions and answers or questions, please put them there. And I will, after the talk is concluded, we'll address those questions as we go. So I'll turn it over.
Cool. Thank you. Should I
Yep.
start?
All you.
Okay. Yeah. So thanks, Matt, for introducing me. I'm pretty new here. I do, as you know, I do GIS, GeoAI stuff, and also I teach GIS courses. And we're seeing a very, we can say it's a rapid, but also very profound change in the community of GIS. If you attend like the conferences like AAG or AGU stuff, where a lot of GIS science technicians work, that they meet and work there, you found like the symposiums or sessions or seminars about how AI is used in GIS, or sometimes we just refer to it using one word called GeoAI. So these discussions are just you know they're just become more and more a dedicated time to talk about this. If you go and check the AAG, they have symposiums. I think I remember when we started about like 2020 or 2021, there was only one symposium with maybe two or three sessions, but now at AAG, the sessions or the symposiums about GeoAI or anything that's related to AI, I think it just makes up maybe one third of the total symposium. So people are really interested in this. And also, I think that people are having many different ideas about this. Some like someone say like if you are working with remote sensing images and you know when you're working with remote sensing images you don't really look at the images, right? You have some algorithms to help you detect buildings or detect the fire, detect the smoke. They say this is what AI is in GIS. And there are also some scientists who have been trying to integrate large language models like the ChatGPT you have been using. I know sometimes for your homework, but you don't, I mean, like, but you don't tell your professor. But so some people say like if you have ChatGPT and if you try to use ChatGPT to answer geospatial questions, like you can actually can do this. Like you can just upload a map and ask ChatGPT, please tell me something about this map, and ChatGPT will give you some answers. Someone say this is the AI for GIS, and there are a little bit more advanced topics like, for example, Professor Lee from Penn State. He's been doing things like, you know, if you work with S3, you know, you use the ArcGIS Pro, or maybe you use the open source version of that, which is a QGIS. They have developed some kind of the prompt-based tools where you talk to that robot, and the robot writes the QGIS codes or does the ArcGIS Pro API call for you. So these are you know many versions of the things that people consider as GeoAI. But today I'm going to talk about a little bit more. Um, I mean, I shouldn't call it fundamental, but I would say it's a little bit more a technical layer, which is a little bit deeper into how AI works, which is called spatial representation learning. It might be some of you might have heard of the word representation learning, which is kind of the keyword ever since the computer vision and natural language processing era. I mean, for computer vision, it's like 2015. It's 10 years ago, and for the natural language processing, I don't know, 2017 or 2016. That's also almost 10 years ago. Like the basic idea is like that when we humans see the world with our eyes or hear the world with our ears, everything is perceived using a we say it's not a biological device. You know, your ears, your brain, and your eyes, they're biological, and everything is made of organic stuff. But when you put the same stuff into a computer, into an AI program, the AI program doesn't have the neurons as humans do. They have very different conductors, they have very different devices to perceive this. So we can't just to put the world in its raw form to the machines, but we need to represent it with something that is more understandable. So it's the same concept. Like when we are working for, so the things are like this. If you're working with paper maps, if you remember in the very old days, when you try to put layers together, you need to have the kind of the transparent maps where you can stack things up. So you can see the different layers stacked together. But once we switch to GIS, when we switch to computers, you found like it's so easy to put different layers together and move layers when you're working with a computer because everything is stored as a kind of digital as a kind of digital storage. But now when it's AI, the thing becomes a little bit more different because now the modern neural networks, they are based now, as we say, neural networks. It's about different digital neurons connected together. They share weights. They work in a very different way from what we're used to, like in the GIS era, where everything is database, everything is spatial join, everything is spatial relations. Those neural networks don't really work in a symbolic way. Sometimes we call it symbolic versus neural approach. So the typical GIS approach, the representation is very symbolic. Everything is represented as points, lines, connected networks. That's how that works. But the modern AI doesn't look at the world in that way. It look at the world as weights, or we say dense matrices. So we need to try to transform the representation of the symbolic GIS world into a more, we say, dense matrix based AI world. So some I'm going to show some slides very quickly. It comes from my talk at Google, but this is a this is a very brief introduction, giving you a little bit pictures about like thinking of like why spatial representation learning is important or is fundamental to AI in GIS. So as we say, this is something I actually talked with words. Like you have maps in the original cartography, everything is plotted on a plane. So there are a lot of stuff that's used to kind of oh, by the way, can you see this screen? You can see it, right?
Yeah, you're good.
Okay. So everything is designed to show things more, you know, more clearly on a 2D surface. And when you go to GIS, and since you're working with computers and you can have multiple layers, so you can stack a lot of things together and you do analysis across layers. And for the AI stuff, as we say, everything is neural network. So we have so neural network is based on forward computation, which is the forwarding of data into the model, and then something called back propagation, which is how you update weights depending on what you learned from the data. So everything is designed this way, and you can see it's really difficult. It's not that easy to put layers into neural networks. You have to represent that in a different way. So that comes the spatial representation learning, or sometimes we call it SRL. It's about like how you transform the various types of spatial data, such as points, polylines, polygons, graphs, or we call networks. How do you transform this stuff into an AI readable form? This is something we call SLR. A very, a very successful example of this is something called location encoding, where how you represent the points on Earth as a vector, which can be used by neural networks. So people found that if you just input the coordinates of points into an AI model, AI doesn't recognize it and doesn't work well with that based on a lot of uh, mathematical facts. The most important thing is about something you might have heard of, which is the projection distortion, especially near the poles. Since the spherical coordinates we use for the latitudes and longitudes, they're based on we call it the spherical geometry, and the common AI models, they work in a Euclidean space. So these two things, you do not have a simple, easy, distortion-free mapping. So we need to do some transformation here. And the typical ways of doing that is having a position encoder, which is because of the PE, which is transforms the local coordinates into some kind of Fourier decomposed series of signals, and we use a neural network to learn the mapping relations between the spherical coordinates and the Euclidean representation. So one of the most straightforward motivation for this of using Fourier transformation is that we found a lot of phenomena, especially in the physical world. It has a very strong multi-scale property. Like, for example, if you just look at the spatial distribution of Mediterranean climate, it's not just in one place, it's everywhere. Like it can be in Mediterranean, where its name comes from, in Italy, in Greece, in Spain, and it's also spotted on the western coast. So you know, like California is actually a very typical Mediterranean climate region, and then you also have something in South America. And for all these kind of distributions, you really have to take the potential distortion into consideration, because if you are local, as we say, um, the local space, the local tangent space of a sphere can be well approximated by a Euclidean space. So that's why when you work on the very small scale model, you can just use the coordinates. Everything is fine. You wouldn't encounter problems. But once you scale up and look at the world, when a lot of stuff is scattered all over the world, you have to transform that things into a multi-scale signals, which is using a Fourier transformation. So these are the very typical ones. And today I'm going to talk a little bit about one of my work, which is new to the community, which is like people are talking about location encoding, where you transform the information on a GIS map into an AI understandable format. But the inverse problem can be even more difficult, which called location decoding. The question is, yes, your AI model uh, works. Your AI model makes a decision or comes out with an answer. That's cool. But that answer, as we said, is in the form of a Euclidean space, right? You still need to map the AI answer back onto your sphere. How is that possible? So this is something called location encoding. So just to summarize that, the location encoding problem, which is the forward problem, is saying, how am I going to describe the things happening on the Earth properly to an AI? And the inverse problem, or the location decoding problem, is saying, how can I understand what AI knows about this world? Because AI talks in its own Euclidean space, but we want to map things back to the sphere. So this is one of the things that I did is skip some of the stuff. Well, so I'm quickly go through this because there might be too many details. The thing is like location decoding is much more difficult than the location encoding problem. The reason is, well, if we talk about its the actual reason is because we say the location encoding algorithms we use today, they are kind of a low rank matrix transformations, which means you actually lose information during this transformation. So if you do that back, I mean, like it's a little bit like you have to do interpolation if you don't have enough data for all the points on the map. So going back is very difficult. And what I did, which is something we called SHDD, or spherical harmonics Dirac delta function representation, it's trying to solve this problem by making the location encoding step as a full rank transformation on matrix. And you know, a full rank transformation of matrix can always be inversed, can always be inverted using another set of matrix transformations. So again, skipping all the very dense details, the bigger picture is if we represent a point as a distributional function on the sphere, we can always decompose that into a series of smooth functions, and these functions can do transformations not using a matrix low ranking way. And we skip the okay, so these are some of the equations that actually support the entire computation. But then let's look back at what it actually does. It does is like you can visualize how AI guesses a place. So the entire thing is, if you give a picture to an AI and ask the AI to guess where this picture is taken, is something called geolocalization problem. Like you could give you a picture, please guess where it is, right? So like you can give an Eiffel Tower picture and the AI guesses this is Paris. That's what it does. But so by using this new representation, you can actually see. So here the backward process or denoise in this process is how AI makes decisions. You can see the AI at the first steps has a so like the brighter the color is, the more certain or more confident the AI thinks that the place is. So you can see as the AI keeps thinking, uh, it has a more and more clear idea of where the picture is taken on the Earth, which we plotted this. And one of the cool thing we did, as we summarize here, is so the new representation makes the encoding and decoding process an error-free stuff, which is not doable before. And also we accompany it with a diffusion, a latent diffusion structure to learn the stuff, which is the geolocalization evaluation. We make AI guess picture places using the representation. And there are many future works we can try to do. For example, we can do polygon decoding. So you can so there are works that tries to transform polygons like building footprints into AI representations. Another question is also the inverse problem. How can we generate polygons using AI based on what we know? So these are some examples of how the representation learning can be used to help transform GI science. Thank you.
All right. So I'll let you if you want to stop sharing there so we can kind of get into some
Mm-hmm.
conversation things. So I don't see questions yet. People, I'm sure will pop in questions as we go here. But I know that there are lots of things that so I get to teach things like data
Mm-hmm.
science and AI from that end without the map. My background is in
Mm-hmm.
mapping. So
Yep.
so I have that sort of joint background. So I always think about how you kind of explained this, the idea that you're going from one coordinate space to another very much relates to projection
Mm-hmm.
activities. Conceptually, and I always use that as an example in teaching things like K nearest neighbors and K
Mm-hmm.
clustering and that stuff, because literally you're operating in multidimensional spaces
Mm-hmm.
that you don't have spatial reference for. So I think that's a really good way to approach this conceptually. So one of the things that I wanted to mention is that I know that you've been part of an editorial team
Mm-hmm.
for upcoming books about
Mm-hmm.
GeoAI. So I didn't know if
Yep.
you wanted to give sort of a scope of the types of chapter titles that were in there that might give some people some ideas of
Mm-hmm.
like how wide this field might actually be. Uh,
Mm-hmm. Yeah, sure. About that book, which I think Yano just sent everything to the publisher.
yep.
I am responsible for three chapters. One chapter is about the mathematical foundations, where we put a lot of equations there about like um, like, the mathematical tools we use for the typical geostatistics world is quite different from what we're using now. Like for geostatistics, we talk about distributions, we talk about different hypothesis testing, we talk about Morans, and I talk about certain variogram. We talk about a lot of the statistical values that you can use to test something. But for the AI
Mhm.
world, it's more like we talk about loss functions, we talk about the learning curves, we'll talk about the representation spaces. So that's one thing. I think there is a very profound, we say, I can't say it's theoretical shift, but it's more like at least is a mathematical shift from the
Mhm.
tools that people are used to, like people are so used to tools in R, in ArcGIS Pro or in GeoPandas. Like even if you're using Python, it's not necessarily that you're using AI tools, because that's more the statistical way of doing that. And there are many new concepts and new mathematical tools that people need to get familiar with if they want to approach it from the AI perspective. And there are chapters about, we say, representation learning, about like how you represent AI in that. We are things about like the ethics and bias of AI, where you see how these how the or it's more about the shortcomings of AI. Like you can't really
Mhm.
rely on that, because we tested it and we found like a lot of the questions are biased, or it's like imbalanced spatially. And there are chapters about the geo foundation models, which is kind of also some of the frontiers, like how you use the bigger models to perform GIS analysis without having you to do the work, right? Like what's the proper way of asking prompt questions so that AI gives you the correct answer, or about like how you feed remote sensing images into for example, Meta has that segment anything model, which is kind of a
Mhm.
really powerful model that people are a lot of the GIS scientists are actually using that to do to do and they basically do the analysis for them. Like the
Mhm.
remote sensing people, they use the SAM, they build agents on that, like Chilshon from Tennessee, from the University of Tennessee at Knoxville, Like
Hmm.
he's kind of expert of using these new SAM technologies to just do almost 95% of the job that the typical GIS scientist need to do. And also, I mean, like, I haven't read through all the chapters. There are also some other stuff like like knowledge graphs, like the more symbolic versions, like how do you organize information into a knowledge graph, and how do you transform that kind of knowledge into AI readable stuff. And
Hmm.
also there is strong uh there was some kind of strong collaboration between knowledge graph and large language models, something they call the technology is
Hmm.
called RAG, or retrieval augmented it's called retrieval augmented generation, which you're not asking AI to tell you the answer, which can be difficult, but
Hmm.
you provide AI with a set of potential answers and say, please select which one looks most
Hmm.
reasonable to you. And that dramatically improves it kind of improves the quality of the answers. And there are a lot of stuff there. I mean, yeah.
Yeah, so I just wanted to highlight that, you kind of mentioned there's a lot of diversity in this field. There's
Hmm.
there's really a lot of diversity in this field.
Yeah.
And I think that one of the things that I hear all the time from students, and you probably hear
Hmm.
this too, is this found, and I think it comes more from the students that are taking GIS courses to learn GIS as a tool,
Hmm.
thinking about, well, what's the impact of this going to be on that career space over the next 5, 10 years? Do you have any thoughts about that? So I think that's probably interesting to this community because this is a professional group.
Hmm.
Like, what's the impact of those sorts of technologies over the next 5, 10 years?
Yeah. So I think um I think it's kind of inevitable um that we say like there is a revolution, or we say at least it is um I mean the tools you are kind of used to in the past, like you might be used to using databases, you might be used to QGIS or ArcGIS Pro, or all these stuff, and all those skills. My personal opinion is that they will be transformed. Like at least you need to update your skill set to be competitive in this industry, which is what I can envision. I mean, like the good thing is like GIS is kind of slow in following up with that, which means like this may take another 3 years maybe to really like now a lot of people they they make slides with ChatGPT. I mean,
Mm-hmm.
like the people used to write things with chat, but now people generate pictures. And also, Google has their Gemini, also the kind of like the nano banana stuff. I mean, like I attended some AI conferences. People they use the nano banana to generate their posters, and they did a great job. They did a great job with those really new tools. But so now, like the AI community is still focusing the more general, or they say the AGI purpose, where like
Mm-hmm.
generate general purpose texts or pictures, or like Claude is more about generating codes. But as for the more specific GIS tools, people are doing that, but that's not that fast. So I think we still have quite some time to catch up with that, to like to train, or to say to make yourself or to say we say to train yourself to follow up with the AI trends. But um, I think there will be some shocks in terms of like if the only thing you know about is like dragging icons in ArcGIS Pro and making simple maps, then I think that might be heavily affected. But the analytical capability, or to say the decision making capability, is still something that's not that well conquered by AI. So I believe like there well, to summarize that, there will be shocks, but it still takes some time to happen. So like it's still worth catching up with that, like, knowing basic Python, understanding the base kind of like the basic things that you can do with a with a large model, and kind of like learn to build your own agents or own pipelines to make AI do the daily analysis job for you and get used to that. I guess that might be a good pathway. Yep.
Yeah. So I'll say from my own experience, one of the
Mm-hmm.
things that I've noticed is that certain fields or certain sub branches of like the spatial reasoning community
Mm-hmm.
wound up never really being implemented architecturally, but
Mm-hmm.
can turn around with some of these types of advancements and become way more useful. And I think
Mm-hmm.
that that's another sort of thing to think about is it to me it's almost a call to go back to basics in some ways and start to think
Mm-hmm.
about, what are the things that maybe were dead ends research wise,
Mm-hmm.
20, 30 years ago that then
Mm-hmm.
become, much more that help to facilitate some of these things. I'm not asking you really to comment on that, but like that's something to kind of consider is really the heart of these fields. We can think about them as the tool, but really the heart of these fields are geospatial thinking.
Mm-hmm.
And effectively, your skill set is that relative to the machine skill set is trying to um, turn this into Euclidean spaces and do
Mm-hmm.
these sorts of things. And like you're trying to translate between those, and that's the thing that's going to lag behind. So the
Mm-hmm.
things in the tool are manifest of these thinking processes that
Mm-hmm.
become more and more of an emphasis. And one of the things I say to students all the time is I can teach you a tool. I can
Mm-hmm.
teach you a data mining tool. I can teach you a data visualization tool. I can teach you a cartography tool. I can teach you a data mining method. That's
Mm-hmm.
better than teaching you the tool because that method is likely not to change
Yeah.
versus the tool itself will change.
Mm-hmm.
So really what you should be learning when you learn these things is more so what's the methodology behind it,
Mm-hmm.
what's the thought process behind this,
Mm-hmm.
and that shift I think is going to be harder to come by for students
Mm-hmm.
because they see these things as more I got to have that skill on my resume, right? When
Mm-hmm.
in reality what we're talking about is we're talking about these sort of thinking processes, these methodologies, these
Mm-hmm.
transformations, and like being able to prepare for that involves that way more so in some cases
Mm-hmm.
than some of this. Um, some of the tools do themselves, and that's not to say that the tools are irrelevant. It's to say
Mm-hmm.
that there are pieces that will protect people, and
Mm-hmm.
that's the thinking processes are the things that will protect people. And I always caution people you should never use a tool unless you know how it works, right?
Mm-hmm.
Be
Yep.
careful with just blindly accepting things.
Yep.
That's the big one I think in the AI world that people are really connected to is,
Mm-hmm.
as good as some of these large language models are sometimes and some of these other
Mm-hmm.
things, they make lots and lots of mistakes. And
Yep.
if you don't recognize how they make mistakes,
Yep.
that's a huge problem.
Yep. That's
So,
true.
yeah.
Yep.
So I know we just had somebody thanking you for the talk. Does anybody
Oh.
have any questions that they'd like to ask? So I have a raised hand there. Let me see if I can't. You can type that in the Q&A if you want to, Leah, or I can open your mic if you want, if you don't mind your mic being on the recording. Hi, Leah. I just promoted you to talk.
Hi, I'm sorry. That was an accident. I fat fingered my raise hand thing. I'm
Okay, that's
sorry.
fine. You're good. So I'll get you off the hook then. All right, I'm not seeing or hearing anything. So I'm gonna ask a question that I think might be
Mm-hmm.
pertinent for people here. Um, if you are in a GIS career right now, we talked about, what might what might be the types of changes that are coming.
Mm-hmm.
What types of things would you recommend people to use for, say, professional development? For like,
Mm-hmm.
are there short courses? Are there topics that people should look at? That sort of
Mm-hmm.
thing to kind of prepare for potential
Mm-hmm.
changes that might happen.
Mm-hmm. Yeah, very, very, very good question. So it's actually some of the stuff that I said to my students in my class, and also actually did a little bit of change to the syllabus according to that. So I think no matter which stage of career that you're in, or like what kind of like a specific branch of the GIS community you're working with, like you might be working with the forestry, you might be working with agriculture or whatever the stuff. Um, I think it's always beneficial to at least learn some of the coding stuff. So I mean, like maybe you can. The simplest way is to go with Python because that's really that's the simplest thing you can find out. And also, you have a lot of community supported packages. Um, because like um, we say as you said, a lot of like the kind of like the tool stuff, I mean, like it's going to be updated, it's going to change, right? But the thing that really makes a GI scientist valuable is the spatial thinking or the spatial analysis skills. Like like looking at the data, and so like looking at the data and making decisions, it is the core value of having a GA scientist there. So a lot of the data sources and also a lot of the data formats that we use today, it's kind of more and more optimized for the programming languages. As you say, like if you are a person who's familiar with, I don't so like R, or if you're familiar with MATLAB, or if you're familiar with the older ones, like what's the name for that? It's some kind of like data analysis software that a lot of the accountants they use. This start with
Oh, good.
S.
Stata?
Stata. Yeah, 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 yeah. Like I mean, like you have heard of these tools, correct? But nowadays, if you just go and search for some large data, for example, if you're working with the climate or something, like there was some data called net CD or something. They have some
Mm-hmm.
formats which you can use Python to
NetCDF.
easily, yeah, CDF, yes. So there are a lot of formats. So there are many different kinds of stuff. And also, if you remember ArcGIS Pro, they have their own uh, shapefile. Not really shapefile. They have their own kind of zipped file format, which is I think it's the GBD, right? Geodatabase,
Geodatabase,
GDB,
GDB.
Geodatabase. Yes, and so you used to, so you used to need to have the subscription of the ArcGIS Pro account to work with that. But nowadays, if you know how to code, if you know a little bit of basic Python stuff, and you will found there are a lot of open source packages that will allow you to merge into so many different types and sources of data, which you can't do that in one software, because in the softwares they're closed source. Sometimes they only allow you to work with certain types of file extensions, and you need to do the transformations here and there. But if you know some coding, there is a lot of freedom that they can do with that. And also, well, so basically that's my suggestion. Maybe that's it's my bias, because I work with codes, but that really gives you a lot of opportunity, and a lot of new, not really new skills, but that makes you kind of like prepare you for a much wider, you know, tools and data that you can actually use. Yeah.
All right, so we have a question
Mhm.
that's popped up in the
Cool.
question and answer here. Is there the potential that different AI models would yield different results while doing the same type of analysis?
Yes, exactly. Yes. So I can raise a very interesting example here, and that is also why we have these chapters talking about AI uncertainty, AI ethics, or AI bias. So I did some very interesting experiments. So like Missouri, so like Kansas City is actually a twin city. Half of it is in Missouri and half of it is in Kansas, right? So
Mhm.
that's basically on the border. And the thing is like I tried something. I asked different large language models. I asked ChatGPT, Gemini, and Claude, and this different large language model. I'm saying like, hey, I am currently in a hotel that's in Kansas City, Kansas State. I want to go out and find some good food. Can you recommend me some restaurants? And you have found different AI models have very different preferences. So if I remember correctly, OpenAI, which was ChatGPT, it gave me restaurants recommendations that's almost exclusively on the Kansas side of the Kansas City. And Gemini gave me answers that's almost the circle surrounding the hotel I mentioned. It's part of it is in Kansas City and part of it is crossing the border to Missouri. So we found like the AI models, at least currently, doesn't understand very well about like the hidden spatial kind of like the hidden intention when people are asking a spatial question. So for example, if you're asking a restaurant problem, usually you don't really care about if that's on the same administrative border as where you are. But if you're
Until you need a
asking,
passport to do it.
oh
Right.
yes, yes. So I did the same thing at San Diego. I
Hmm.
said recommending me some Mexican food restaurants. Some AIs realizes that, hey, are you a visitor or are you a US citizen? And some AIs doesn't know that they recommend a lot of restaurants across the border. And also a question is like if you are not asking about restaurants, if you're asking about I want to register my car, that is not a question that you can recommend DMVs cross border if you
Yeah.
are a resident of the county. So yes, so AI models are still are not understanding a lot of the spatial intentions. I mean, like yes, they can answer questions that's pretty straightforward, but once there is something hidden there, they give you very different answers. So these are the things. And also, I want to just quickly add one more comment is that sometimes different AI give different answers may not necessarily be a bad thing. It's something we call the AI diversity stuff. So people found like as the AI trained more and more and more, the AI is losing diversity. The diversity is not saying like it's not something like when usually when we talk about like the racial or gender diversity stuff, it's like saying, for example, when we ask AI saying like, hey, can you give me an example of of a typical, let me say, a typical East Asian city. If you ask some question about this, so in the very original version of the AI where they're not that trained or aligned, it gives you a lot of stuff. That gives you Tokyo, Japan, that gives you Seoul, that gives you Bangkok, or a lot of cities. But when we try to do the same thing on the more the kind of the latest version, it gives you Tokyo 95% of the time. That means the AI is kind of like converging to a stereotype of the
Hmm.
places. It's losing diversity. In that case, we want AI to give you diverse answers instead of the placial stereotype. So I think that really depends. So if you're asking scientific questions, you want to reduce diversity, you want AI to converge to the same answer. But if you're talking about more social, cultural, or more placial questions, sometimes you want it to be more diverse. Yeah.
Yeah. So I can add to this a little bit too, is
Hmm.
that from the perspective of, say, things like data mining and machine learning, we
Hmm.
have methods that are called ensemble methods,
Hmm.
which would do
Mul
the same task in multiple
hmm.
ways
Yeah.
and will produce different types of outcomes
Hmm.
based on how they're making the decision.
Yes.
So like the canonical examples of that are things like linear discriminant analysis, naive
Hmm.
Bayes, K nearest neighbors, things like that, that all they're all at the end of the day trying to classify something, but they are potentially providing different approaches. And really, there's the other level of the AI problem is also what data is it feeding off of, right? Because now you can use the exact same algorithm on a different data set and come to a different conclusion because of what was provided to train it. So that's sort of the side effect of the training problem you're talking about here, is that the more you aggregate data sets, the more they converge, versus the more that you have smaller things to work with, the diversity can be much larger, which then relates to the statistics problems of standard deviation changing. So these things are they're all interconnected problems to one another. That's why your stats classes in college were so important, because it relates to it. So are there other questions from folks? Do you mind if people reach out to you with questions via email?
Oh, it does. Yeah. I wouldn't mind. I wouldn't mind.
Yeah, he's pretty easy to find. If you go to the UMaine website and type his name, you'll get to his email. We can put out a message from the GIS user group to share the email address. So I want to thank you for taking the time to speak with the group today.
And thank you for your invitation.
Oh, we've got another question here. Any recommendations on AI and philosophy books, papers, or other things to read?
That's a very good question, but I mean, like, AI has evolved into it's kind of gigantic stuff that it's really difficult to recommend anything that to work on, as a single paper or a single book. Whew. That's a really tough question. So, I think that really
depends on your application, right?
Yes,
like
yes, that's a good answer. That really depends on. I mean, like, no, don't have to sorry, but yeah. No, I would say a very quick question. No, a very quick answer to that. So, if you are trying to do a very specific application, like for example, segmenting maps, or if you're trying to analyze people's like geotagged Twitter comments, things that very specific, you should go and check the latest paper on that specific topic. That's the most helpful one, because a lot of the books that might be written, I mean, like a book that's written 2 years ago might already be outdated. It doesn't help you. So if that's a specific application, go check the latest papers. If you are talking about like having the basic concept of what AI is or the stuff, that really requires you to have a little bit of coding knowledge, and also a little bit of the math knowledge to understand both the original ones. For example, the book called Deep Learning. It's just called Deep Learning by those Nobel Prize winners. That's something written in 2015 or something. You can go check that, but that really requires a lot of preparation to do that. Yeah.
And some things I might say as like I give a reading list to my intro data science students, and I put a diversity of things out there that might pique their interest. Like the types of things like, how is this used in this area, or things that you want to consider more broadly. So one of the books that I put on there is called Code Dependent. It's written in the last year, Living in the Shadow of AI. So if you're interested in like the impacts on life in some sense, and like what that kind of means societally, that's of course always evolving. But things like that do have some bedrock to them, because you can kind of extrapolate a little bit about things that you've seen earlier in that process, and then you've seen them kind of propagate a little bit. So something like that. There are books that are about not so much AI, but they're about things like, how do we come to say why something happened? and using that to kind of get into, well, how does the AI do that? Right. And really starting to get to more the philosophical slants. And some of the philosophical slants are probably much more stable earlier. Right. And then you start to see the technologies getting better, and you start to see maybe some of the fears that the people in philosophy had manifesting. So, stuff like that might be helpful. So to think about towards that reading question. It's really about what you're attempting to do, right? Yep. It's like, is your goal to think about ethics and philosophy? That's a entirely different nut to crack than how does this influence a discipline, right? Those things change more violently, generally. So, all right. Anything else before we wind down? All right. Seeing none, thank you again, and hope to see folks at our and Steve is one of our board members is thanking you for the topic. So
thank you.
Yep. So I will stop the recording, and we will